Hello everyone, this is Saurabh from Edureka. Today's session will deal with a comparison between various configuration management tools, namely Chef, Puppet, Ansible and SaltStack. First thing first guys, let us have a look at the agenda for today. So first we'll understand the DevOps lifecycle, that is various stages in DevOps and the tools that are used in those stages. After that, we'll understand what is configuration management and deployment and why is it that important. Finally, we'll compare the 4 configuration management tools, Chef, Puppet, Ansible and SaltStack. So are we clear with the agenda guys? Kindly give me a quick confirmation by writing down in the chat box. Bennett says yes. Quinn, Janice, Rahul, Arpan. Cool, great. Let's move forward and understand the DevOps lifecycle. This is the DevOps lifecycle. As you can see, it is an infinite loop. It is a never-ending process. It starts from plan where you gather all the requirements for your application, then you start coding for it. After that, the continuous integration servers like Jenkins will pull that code and prepare a build. After that, the build application is deployed onto the test server for testing. Once testing is done, it is then deployed onto the production server for release. After the product is released, it is continuously monitored by tools like NagOS that provides relevant feedback to the concerned teams. This feedback can be anything like the downtime, or is there any defect in the product, or how is it doing in the market. So all those things are fed back to the concerned teams and those teams takes the necessary actions. So I hope you all are clear with the DevOps lifecycle. Let me add this thing guys, let us make this session interactive. You won't even enjoy it if it's a one-way conversation. So any questions, any doubt at any point of time, you are free to ask me. So if you are clear, just give me a quick confirmation. Thank you guys for your confirmation. Now I'll move forward and we'll look at various tools that are used in these stages. So for code, we have Git, Jira, Eclipse, Subversion. For build, we have Maven, Gradle, and Ant. For testing, we have Selenium, JUnit. For continuous integration, we have Jenkins, Bamboo. For continuous monitoring, we have NagOS. For configuration management and deployment, we have Puppet, Chef, Ansible, and SaltStack. So this particular slide is highlighting the 4 configuration management tools that we will compare in today's session: Puppet, Chef, Ansible, and SaltStack. But before we move forward, we need to first understand the reason for using these tools. So for that, we'll have a look at various problems that industries were facing before configuration management and deployment was introduced, or before these tools came into the picture. So we'll have a look at those problems one by one. So the first problem is mass deployment. Let us understand this with an example. Suppose you have opened a business and it is pretty small in the beginning. So if you need to deploy a particular application, say on 5 VMs, it is a pretty easy task. You can do it manually. But what happens when your business becomes huge? It becomes like WhatsApp. Then you need to deploy the same application, say on 500 VMs. So you cannot do that task manually, can you? So what we need here, we need some kind of an automation or some kind of tool that can automate this task for us. Okay, so Bennett has a question. He's asking, why can't we deploy the application on 500 VMs manually? Bennett, first of all, if you do it manually, there's a high risk of human error. Apart from that, it'll take a lot of time. What if you have to finish the task overnight? Tomorrow might be a big billion day sale in your company or a mega sale in which heavy traffic is expected. So you need some kind of a tool that can automate this task for you. Are we clear? Thank you, Bennett, for your confirmation. So let us move forward and have a look at the second problem. Problem 2, migrating from test to production. As you can see that there's a construction guy who is very worried because he has made a blueprint for a house, he has planned everything, tested everything, and when he built the house, it is on fire. You can relate the same scenario with software delivery lifecycle as well, where developers build application which works fine till testing, but when it reaches production, due to the difference in the computing environment, certain functions of that applications are not working properly. This is a very common scenario, and I think a lot of you who are developers can relate to this particular scenario. So what do we need here? We need a tool that can provide a consistent environment throughout the software delivery lifecycle. Let us move forward and have a look at the third scenario. It is about application failure. As you can see that there is a manager who is very angry and frustrated, who is banging his desk and calling one of his employee at 3 a.m. because he has updated a particular software and that is not working properly. There are certain glitches in that software. Now, the manager wants to roll back to the previous stable version of the software. But since there is no accurate historical record of system state available with the employee, he has no idea how to roll back quickly. Obviously, he can do that manually, but it will take a lot of time. Now let us have a look at the case study which depicts this particular scenario. It is about an online travel booking website in UK called thetrainline.com. There are certain stats about it. There is 1.2 billion pounds annual revenue and 9+ million visits per month. So you can imagine a company this big who is generating 1.2 billion pounds of annual revenue. What will happen if there is a downtime in their website? As you can see from the graph that their website went down thrice. So you can imagine the loss, probably millions of dollars. So all these scenarios, all these three problems that we have discussed points down to one single solution, that we need some kind of tool that can automate these tasks for us, that can roll back to a previous stable version, that can provide us with a constant computing environment throughout the software delivery lifecycle, and can automatically scale up and scale down depending upon the traffic. So we need some kind of an IT automation, and or you can say we need configuration management and deployment tools for IT automation. But before we go ahead, we should first understand a very important concept called infrastructure as code. So what is infrastructure as code? Infrastructure as code simply means that you are writing code for your infrastructure. So you are provisioning your environment by writing code rather than manual process. Or you can even term it as programmable infrastructure. As you can see from the slide, that there is one central location where code for the infrastructure is present, and it is being pushed onto three different environments, that is dev, test, and product. Now let us understand infrastructure as code with an example. Suppose you need to install Apache Tomcat on 5 VMs. So what you'll do, in one central location or in one central server, you'll write the code to install Apache Tomcat, and you'll push that code onto the 5 nodes. So what advantage we get from here? What is the advantage of doing that? First of all, you don't need to manually go and install in each VM Apache Tomcat. You just need to write the configuration in one central location and replicate that on the nodes. Apart from that, you have an accurate historical record of the system state. So whenever you have, even if you have updated a software that is not working fine, you can always roll back to the previous stable version. So I want answer from you all guys. Is there any other advantage that you can think of infrastructure as code apart from the ones which I told you? So Janice says that it increases the release frequency. Definitely it does, because you can provision your environment within minutes or seconds, which earlier used to take probably hours or days or weeks. So definitely Janice, this is one major advantage. Is there any other advantage that you guys can think of? Okay, we have a question from Quinn. He's asking how infrastructure as code is addressing the previous problems that we discussed. Very nice question, Quinn. So if you can remember the third problem where we discussed application failure. So what happened there? There was a software which was updated and there were certain glitches over there. So they needed to roll back to the previous stable version. With infrastructure as code, you have an accurate historical record of your system state present in one centralized location. So there is no problem in rolling back to the previous version of the software if you have updated with a flawed version. Now let us recall the second problem that we discussed, that is the difference in the computing environment between testing and production. Over there, if we apply infrastructure as code and write the configurations that will provide the same environment, exactly the same environment in the three different teams, then that problem will easily be solved. Those three teams can be dev, test, and product. If you can recall the second problem that we discussed, migrating from test to production, over there, if we use infrastructure as code and provide the same computing environment in the two teams, that is test and production, then that problem will easily be solved. So if you can recall the first problem, that was mass deployment. Over there, if you have infrastructure as code, so you just need to write the specifications, or you just need to specify the IP address or the host name of the nodes that you want to configure. So if you want to configure 50 nodes today, and suppose tomorrow you might need to configure 500 nodes, so you just need to specify the IP address or the host name of the nodes that you want to configure in that central location, and that's it. That's it. That's all you have to do. I hope this answers your question, Quinn. Thank you for your reply. So we have one more question that is from Rahul. He's asking, due to this continuous read-write operation, will there be data inconsistency? Absolutely no, Rahul. What happens is there's no read and write operation. Either there's push mechanism or pull mechanism. In pull mechanism, the nodes will actually pull the configurations from the central location or the central server, or in push mechanism, the server will actually push the configurations onto the nodes. So there's no read and write concept over here. So any more questions, guys? If you all are clear with infrastructure as code, I'll move forward. So let us move forward and compare shell script with the configuration management tool script. There are three key metrics on which we will compare the shell script and CM tool script. First, in shell script, you need to write the automation script from scratch. But when we talk about CM tool script, 80% of things are already present. Second of all, in shell script, you need to define workflows. But in CM tool script, the workflows are already there. For example, in Chef, we have run list, similarly for other tools as well. The third difference is that shell script does not have a user interface, whereas CM tool script provides you with a user interface. So any questions, guys, just write down in your chat box. All right. So you have understood the concept of infrastructure as code. Kindly give me a confirmation. Bennett says yes. So does Quinn, Rahul, Arpan. Cool, great. So now let us move forward with the most awaited topic of today's session. That is the comparison between Puppet, SaltStack, Ansible, and Chef. But first, let us have a look at the metrics or the factors on which we will compare these tools. So the first factor will be scalability. After that comes ease of setup, then availability, management, and interoperability. So let us compare the tools on the basis of scalability. All the four tools are highly scalable. What does that mean? Suppose if you need to configure around 50 nodes today, and tomorrow might be a big day in your company, and you need to configure around 500 nodes, not a problem when you have tools like Puppet, Chef, Ansible, and SaltStack. You just need to specify the IP address or the host name of the nodes that you want to configure in that central location, and rest of the tasks will be handled by these tools. And let me tell you that these tools can handle large infrastructure. It can be workstations or any sort of infrastructure. So I hope I'm clear, guys. Is there any doubt? So should I move forward? Just give me a confirmation, guys. Thank you, Bennett. All right. Thank you, Janice. And let us move forward and compare the tools on the basis of ease of setup. Over here, I'll add my personal experience, guys, because when I was installing Puppet, Chef, and SaltStack, I faced quite a lot of issues. But when I was installing Ansible, it was just like a cakewalk. Let us focus on each tool one by one. First is Puppet. Puppet has a master agent architecture. So in that Puppet server, you need to install the Puppet master, and in the clients, you need to install Puppet agent. After that, there is a certificate signing between the agent and the master. When we talk about Chef, it also has a master agent architecture. In the master, you need to install Chef server, and in the agent, you need to install Chef client. But the major difference between Puppet and Chef is that Chef has an extra component called workstation. This workstation is actually a machine that contains all the configurations, and these configurations are tested on the workstation, and then it is pushed onto the central Chef server. Same goes for SaltStack as well. Here the server is called as Salt Master, and the clients are termed as Salt Minions. But when we talk about Ansible, I'll tell you what you have to do to set up Ansible. Just install Ansible on your master machine or your control machine and do an SSH connection with the nodes you want to configure. That's it, guys. That's all you have to do to set up Ansible. I know it's very, very easy, and I myself have done it, so I can tell you that it is the easiest tool to install among the four. So are we clear here, guys? Any questions, any doubt? All right, so no doubt. So let us move forward and compare the tools on the basis of availability. All the tools are highly available. Basically, what does that mean? That there are multiple masters or multiple servers or multiple instances that can be present. So if your main master or main server goes down, there's always a backup server or the different machine or a different master to take its place. Let us have a look at each tool one by one. Puppet has a multi-master architecture. That means there are multiple masters. So if your main master goes down, then there is definitely a backup master who can take its place. In Chef also the same case. If your primary Chef server goes down, then you always have a backup server to take its place. Same goes for SaltStack as well. It has multiple masters to configure Salt Minions. And when we talk about Ansible, it has primary instance. If it goes down, then there's always a secondary instance to take its place. I hope I'm clear, guys. It was a pretty easy concept, but still, if you have any doubts, you are free to ask me. So I'll move forward and compare the tools on the basis of management. So I'd like to add this thing that before I explain you, I'll tell you Puppet and Chef follows the pull configuration and Ansible and SaltStack follows the push configuration. All right, so we have a question from Arpan. He's asking what is pull and what is push configuration? Can you explain with an example? Sure, I can. Say you need to configure around 50 nodes and there is one central server. So what happens in push configuration? All the configurations that are present in the central server will be pushed by that server onto the nodes. All right, so there are certain commands that you need to execute on that server in order to push those configurations on the nodes. But when we talk about pull configurations, the nodes constantly poll the central server for configurations, and it will automatically pull the configurations from the server. You don't need to execute any command on the central server. So I hope you guys are clear with the concept of push and pull configurations. Thank you, Arpan, for the confirmation. So Puppet follows pull configuration, so does Chef. But when we talk about Ansible and SaltStack, both of them follows push configuration. Now Puppet is not easy to learn because it uses its own language called Puppet domain specific language. And since it is a new language, so it is tough to understand. It is quite system administrator oriented. Now when we talk about SaltStack and Ansible, both of them uses YAML, which is basically a common English that we use in day-to-day life. For example, if I want to install something, so I'll just write install and the name of the package or the name of the software that I want to install. I hope I'm clear. Any doubts, guys? Any doubts? So if we are clear, just give me a confirmation. Thank you for your confirmation, guys. Let's move forward and compare the tools on the basis of interoperability. All the four tools, their main master or their main server or their control machine has to be on Linux/Unix, but their slaves or the nodes that they have to configure can be on Windows. Let us have a look at each tool one by one. For Puppet, Puppet Master works only on Linux or Unix, but Puppet Agent also works on Windows. For Chef, the Chef server works on Linux or Unix, but the Chef client and workstation can be on Windows as well as Linux or Unix. Same goes for SaltStack as well. Salt Master can work on Linux or Unix, and the Salt Minions can work on Windows as well. And when we talk about Ansible, the Ansible control machine or the Ansible server has to be on Linux or Unix, and the nodes that it is configuring can be on Windows as well. So any questions still here, guys? Any questions? Okay, so Janice has a question. She's asking why always the master or the server is on Linux or Unix. Janice, there is no proper explanation about this anywhere present, but still I'll add my experience and I'll try to answer this. First is the security. That is the Linux or Unix is more secure when compared to Windows. Second is Linux is faster than Windows. And third can be it is open source. So I hope this answers your question, Janice. Thank you for the confirmation. So I'll move forward and I'll show you the final scorecard that I have prepared. So this scorecard I have prepared with my experience and my observation, and I've given equal weightage to all the parameters, that is scalability, setup, availability, management, and interoperability. You can give the weightage to these parameters the way you want. All right, so Rahul is asking us, according to your scorecard, Ansible scores 9. Is it the best tool? Rahul, there's nothing like best tool. I'm providing you with factors and matrix to compare the tools. So all the tools have their own pros and cons. So it depends totally on your organization's need and your organization's environment, which tool will fit in your organization, that you are the best judge. So this is my observation and my experience that I've put in to create this scorecard. I hope this answers your question. All right, so have a look at the scorecard. When we talk about scalability, Puppet, SaltStack, Chef, and Ansible all are scalable, so I've given them 9. But when we talk about setup, Puppet, SaltStack, and Chef are not that easy to set up when compared to Ansible. So Ansible scores 9, rest of the tools scores 8. When we talk about availability, all the 4 tools have multi-master or multi-server architecture, in which when the base server goes down, there's always a backup server to take its place. So all the tools scores 9 over here. When we talk about management, Puppet and Chef are a little tough to understand when compared to SaltStack and Ansible. So SaltStack and Ansible scores 9 and Puppet and Chef scores 8. Interoperability. So as we have seen that all the four tools, their main master or server is present on Linux/Unix and their slaves or nodes can be on Windows. So all of them scores 9 over here. So final score for Puppet is 8.6, SaltStack is 8.8, Chef is 8.6 and Ansible is 9.0. So are there any questions, guys? No. So let us move forward and see some of the more factors. So let us move forward and we'll see some more factors or more metrics on which we can compare these tools. So first is configuration language, second is GitHub activity, then comes enterprise cost, popularity and success story. So let us compare the tools on the basis of configuration language. So as I've told you earlier as well, Puppet uses its own Puppet domain specific language, which is not very easy to understand. And it is kind of system administrator oriented language. When we talk about Chef, it uses Ruby domain specific language. So if you're working with Chef, you need to have some kind of Ruby knowledge in order to work with it. When we come to Ansible and SaltStack, they use YAML. And trust me guys, when I say this, it is very easy. It is just like common English. As I've told you earlier, the way you communicate with people in your day-to-day life, it is that simple. Suppose if I'm installing Nginx, so I'll just write install Nginx. So should we move forward? Are there any questions from your side? Just write it in your chat box. All right, so we'll move forward and compare the tools on the basis of GitHub activity. So there are certain stats. Puppet has 355 contributors, 19,595 commits, 9 branches and 291 releases. SaltStack has 1,041 contributors, 49,193 commit, 11 branches and 82 releases. When we talk about Chef, it has 369 contributors, 12,089 commits, branches are 177 and 231 releases. For Ansible, there are 1,003 contributors, 13,527 commits, 33 branches and 57 releases. Okay, so Quinn is asking why SaltStack has 49,193 commits more than any other tool. There are multiple reasons for it. The two major reasons that I can think of is they have a huge active community that is contributing to SaltStack. Apart from that, there might be many revisions or many changes done in that tool. So these are the two major reasons that I can think of for the amount of commits that you are seeing on your screen. That is 49,193, which is more than any other tool. So any other doubts or should we move forward? All right, fine guys, we'll move forward and compare the tools on the basis of enterprise cost. So enterprise cost for 100 nodes per year is as follows. For Puppet, it is $12,000. For SaltStack, it is $15,000. For Chef, it is $7,200. And for Ansible, it is $10,000. Now let us move forward and compare the tools on the basis of popularity. This is the Google trend graph for past 5 years. Let me tell you guys that Puppet and Chef are the old players. They are very mature and well-established tools. Most of the industries across the globe recognize both of these tools. But when we talk about SaltStack and Ansible, they are new to the market. And as you can see that the green line of Ansible is trending. It is growing day by day, probably because of ease of setup and easy to use. These are the two major reasons why Ansible is becoming so popular nowadays. Many giants like NASA are using Ansible to provision their environment on cloud. So let us move forward and compare the tools on the basis of success stories. New York Stock Exchange Intercontinental Exchange is using Puppet. They have increased from 300 servers per admin to 700 servers per admin, and they are provisioning their dev environment, which used to take 1 or 2 days, in just 21 minutes. So isn't that great? So they are provisioning their dev environment with the help of Puppet, which earlier used to take 1 or 2 days, but with the help of Puppet it is just taking 21 minutes. That is amazing. When we talk about SaltStack, LinkedIn is using SaltStack, and earlier they were using 5,000 salt minions around 4 years ago, and now they're using 70,000 salt minions. So Gannett is using Chef, and earlier 30% of Gannett's technology organization were using Chef, but this year they have converted that 30% to 100%. Isn't that amazing, guys? When we talk about Ansible, FatMap is using Ansible, and they say that with the help of Ansible, they are able to cut down certain processes which used to take 17 hours to 3 minutes. That's amazing. Any doubts still here, guys? Any doubts, any queries, just write down. Cool, great, we'll move forward. So by now you must have selected the tool on the basis of your organization's need and your organization's environment. I'm not saying that any of the tool is better than the other tool. I've given you with factors or matrix that you can compare the tools on. The final decision is yours. All the tools have their own pros and cons. So with this, I will end today's session. If you have any questions or queries, just write it on the chat box and I'll be happy to help you. This recording will be available in your LMS, so you can watch it. And if you have any doubts after watching this recording, you can connect with our support team. We have a 24/7 support team that will be helping you out with your queries, or you can bring your questions in the next class. And kindly give us your important feedback. This will help us to improve the quality of education that we provide. Thank you and have a great day.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!